Right, for those doing statistics, here is the question paper that we are going to look at. February, March 2020. The paper is 1 hour 15 minutes. Paper is 1 hour 15 minutes. I'm going to start from the bottom. I'm just going to give you hints on how to attempt, then you answer. Then the other question, I'm also going to give you the hints during the class lessons, right? So if you look at the last question, we have a graph. We want to draw a cumulative frequency graph. So I'm going to explain how to draw it on part A, then part B, and so forth. You are going to answer it on your own. Right, so here we are given a data. Helen measures the length of 150 fish of a certain species in a large pond. These lengths correct to the nearest centimeter are given this one. Draw a cumulative frequency to illustrate this data. So the first thing you need to identify here, you have to identify whether your data is continuous or not continuous. So in this case, our data is not continuous. Why? Because there are gaps here. We've got these gaps. So if you still remember, we said how do we close these gaps? We close these gaps by using this plus or minus 0.5, where we said we subtract 0.5 to the lower limits, then add 0.5 to the upper limit. For instance, if we this one is our lower limit, if we subtract all these lower limits, we subtract all these lower limits 0.5, and the upper limits we add. So in this case, we are going to, so you have to redraw this the table. So you are going to have negative 0.5. You're going to have negative 0.5 up to 9. Here is the upper limit. We add 0.5 and get what? 9.5. And here is the lower limit. We subtract 0.5. What do we get? We get 9.5. So the moment you are doing this, you'd see that the gaps will be closed. The gaps will be closed up to 14.5 and so forth and so forth. So you have to complete the table. Right. Then the next step, you have to come up with a cumulative frequency. You come up with a cumulative frequency. You come up with a cumulative frequency. You come up with a cumulative frequency. How do you come up with a cumulative frequency? So this is our cumulative frequency. You find the cumulative frequency from the frequency. You start with this 15. You have this 15. So with this 15, you add 48. 48 plus 15, you get this value. This value plus this value, you get this value. This value plus 21, you get this value. And you are going to see that this value is going to come up to 150. This value is going to be 150. It is going to be the total. It is going to be the total of this. It's 150. So how do you draw the cumulative frequency after completing that table? Right. I think if you don't have this, you have to write down. You plot cumulative frequency on the y-axis. This is our y-axis. You have to write cumulative frequency on this y-axis. You have to write cumulative frequency. Then on the x-axis is where you have your classes. On the x-axis, you're going to put your classes. In this case, it's our length. In this case, you are going to put your length. I'm not going to discuss with you the scale. You come up with your own good scale which is suitable. Then after that, you plot the upper limits, which is 9.5 in this case, with cumulative. So we are going to plot We are going to plot 9.5 with 15. Then you come here, the upper limit here, it's please you do with the upper limits only. 14.5 with this value, the cumulative. And the next upper limit, then you have to join by freehand. It will come up with like a curve, to come up with like a curve in this shape, a shape like this. I'm not saying this is the original, but if you join the points, you're going to come up with this type of graph. So you can read B, you can attempt B, can you do B and C? I have give you the hint to attempt number 7. Let's move on to number 6. Number 6. Number 6 here is a tree diagram. We have a box A that contains 7 red balls. Box A contains 7 red balls and 1 blue ball. Box B contains 9 red balls and 5 blue balls. A ball is chosen at random from box A and placed in a box B. A ball is then chosen from box B. The tree diagram below shows the possibility for the colors of the ball chosen. So we are going to select a ball from box A, then put it in box B. Then in box B, we are going to select either a ball again. So we want to complete this tree diagram and show all the possibility. So let's start with the box A. How many red balls do we have? We have 7. So this is straightforward. We have 7. Out of what? How many balls altogether? 7 plus 1, which is 8. So the probability here is 7 over 8. And obvious here it's 1 over 8. Because if we add these two, we must get 1. Then if we are to select a red ball and put it into box B, the red balls will be 10. The red balls will have 10 red balls. Suppose we are selecting a ball from box A, then put it in box B. So if we select red and put it in box B, there are going to be 10 red balls and 5 blue balls. So meaning to say there will be 15. So selecting a red ball, it will be 10 over 15. It will be 10 over 15. And here for blue, it will be 5 over 15. I want you to complete this one. I've done this one. I'm saying I have selected a red ball and put it in box B. So if I put a red ball in box B, there are going to be 10 red balls because already we have 9 red balls. So if we put a red ball, there will be 10. So the probability of selecting a red ball will be 10 over 15 because it's 10 plus 5 blue balls. So I want you to do the same thing here. If you select a blue ball and put it in this one, what values are you going to get here? So you can complete. So part B, find the probability that the 2 balls chosen are not of the same color. Please use your tree diagram. Use your tree diagram to answer B and C. Use your tree diagram to answer B and C. I'm just giving you hints. Right? On number 5, in Greenton, 70% of adults owns a car. A random sample of 8 adults from Greenton is chosen. the way you are reading the question, you would have just find out which distribution is this. We have n and we have p. These conditions satisfy a certain distribution which we refer to binomial. We are given p and n, so automatically it's binomial. Where we say binomial x follows binomial with n, which is 8, then we put our p. I think you now remember. I've just given you a hint. Find probability that the number of adults in this sample who own a car is less than 6. So we want to find this probability. P of x less than is this one, less than 6. Then you calculate. Then we are going to have a random sample of 120. Again, using the above, our n is changed. X now, our n is now to 120, which is now big. So there's a certain approximation. I want you to find that approximation. Where we say for the binomial, if n is very large, which approximation do we use? And they are now saying a find probability of more than 75. Okay, let me give you the hint on this one. You change it to binomial, to normal, where we say the mean will be np. The mean will be np. Here it's your n and your p. And from the binomial, how do you find the variance? It's npq. It's npq. So then you have to find the probability of what? You have to find the probability of more than 75. So our x is more than 75. Then what do you do? You use your continuity corrections. Use continuity corrections. Then you complete. So I will also give you hints on the remaining questions during our class lessons. So for this one, the due date is also 22 February. You have to submit the paper on 22 February.